Okay, so we're gonna go ahead and get started on example 1. And today what you're gonna do is you are going to find the scale factor, but the scale factor as a percent, which is how much an image or an object is getting bigger or getting smaller depending on the context of the problem. So here's our problem. It says when you bake a cake, the batter gets bigger as it bakes in the oven, very similar to a cookie. So during this quarantine, Ms. Mustafa, me, has been baking a lot. Very true, because I love math and was clearly bored, which is also very true. I measured the diameter of the cake batter and found that it was 3.5 inches. After the cake finished baking, the diameter was now 5 1/4 inches. By what factor does the cake expand? Okay, which means like, what's the scale factor and how much is this cake getting bigger? That's basically what this question is asking you. And on the bottom here, you have a percentage of how much it's getting bigger by. Okay, so first thing is I'm going to head over to the notebook, and what I have is the CFS already written down. What I want you to do is you're going to actually pause and you're going to draw these two circles, and then you're going to write down scale factor here. Okay, so now hopefully you've paused your video, drawn this out, and number 1 says in your CFS, determine the initial value and the final value. So we're talking about the cake batter, and this was the cake. I'm just gonna put baked because what I measured was the cake batter and then after, once it got bigger. Okay, so the cake batter is the initial value. Initial means the original value. Okay, and the cake baked obviously is the final value, so after it got bigger. So this is my final or the new value. Okay, so the first thing I did was I determined what's the initial, what's the final. Great. Now, determine if the scale factor is less than 100% or greater than 100%. So, because in this problem, this cake batter got bigger, I'm going to say that this scale factor is going to be greater than 100%. Okay, so now what we're going to do, so we're going to check this off, is on the bottom, here's what you're going to write down. Your scale factor is always the final value, because you're comparing the final value, and you're going to divide it by the initial value. That's the ratio of my scale factor. It's the final to the initial, because you want to figure out, well, how much is the final value getting bigger by or smaller by compared to the initial value, what you started with. Okay, so second thing. In this example, it talks about the diameter. What the diameter means is literally just, if you look at the middle of the circle, it's the length from one end of the circle to the other end of the middle of the circle. So I'm gonna like kind of estimate the middle of the circle of here, since we're talking about the diameter. And this is the diameter. Again, it's the length between the middle end of one of the circle to all the way to the other end of the circle. Okay, so the diameter is originally 3.5. And 3.5 is the same as 3.5. And then it got bigger by 5 1/4, which is the same as 5.25. All I'm doing is writing the equivalent value of this mixed number as a decimal. So 3.5 is the same as 3.5, and 5 1/4 is the same as 5.25. Okay, so now what we have to do is, if I want to find the scale factor, if I want to know how much this got bigger by, I'm going to divide my final value, which is 5.25, by the initial value, which is 3.5. So now I'm going to substitute. We're going to put 5.25 inches over 3.5 inches. Now what I'm going to do, since all of you I'm sure have your phones, we're just going to take this calculator and we get 5.25 divided by, let's do 3.5, and what you get is 1.5. Okay, so the scale factor is 1.5, but here's the catch. Okay, so in our CFS we did a check here. Now we divided the final with the initial and we got 1.5. That is my scale factor, but it's not the percentage. And the question is literally asking, what is the percent? It says, by how much did it expand? And we're looking at the scale factor as a percent. So already, if I look at this, it's definitely not 66. It's definitely not 6.6. And if I'm looking right here with 1.5%, I already know that my answer has to be 150, because if your object is getting bigger, remember the scale factor means it's greater than 100%, which means the only option really could be my last one. But I need you to pay very close attention because I know a lot of you will make this mistake. If my scale factor is 1.5 and it's asking me to convert this into a percent, this is our second, convert decimal to a percent. Remember that percent means, percent equals per 100. That's what percent means. So if I want to turn this number into a percent, I'm going to do 1.5 and I'm going to multiply that by 100. Okay, so if I take 1.5, I multiply it by 100. We could literally just do this right here. So 0, 0, 5. And then 100 times 1 is 100. Oh my gosh. I'm going to do 0, 0, I apologize, 5, 1. So you get 1,500. But because there's one number behind the decimal, I'm going to put 150. So this would be 150%. So as said before, the cake got bigger by a scale factor of 150%, which is the same as 1.5. And that cake looks amazing. I didn't cook that though.